We're now going to end our presentation today with chiller basics. On the screen, you will see some information from one of our many educational materials. And right off the bat, you can see there are two main types of chillers, and those would be water-cooled and air-cooled. And there you have the answer to that last knowledge check question. The two main types of chillers are water-cooled and air-cooled. Chillers are very complex systems for sure, and we probably could spend an entire 90-minute session breaking them down. But today we have limited time, so we'll be keeping this at a high level review. But if chillers are new to you, I'm confident we will be offering some great information on how they work and some of the major components. Water-cooled systems are the larger, more complex type. They will cost more upfront, but will also last longer and be more efficient. These types are best suited for those medium to very large facilities. Air-cooled chillers are better for small to medium facilities, have cheaper installation costs, will require less maintenance, and take up less space. This slide is probably a bit overwhelming. Remember that I mentioned that these systems are complex and technical? These diagrams are a pretty good indication of that. And I promise we won't go too deep into the details on these, at least at this point. But there is one key concept I want to get across here, which is the main difference between water-cooled and air-cooled systems. And that is how the systems eject or get rid of the heat they gather inside the building. Air-cooled systems get their name since they use a coil in the outside air to dissipate heat. This is very much like a standard split system or package unit, which also use an outdoor coil in the same fashion. In contrast to that, a water-cooled system uses water to dissipate heat outside. This is accomplished by transferring heat inside the building to water, then pumping that water to a cooling tower to dissipate that heat. Water is used since water conducts heat about 25% better or faster than air alone. Now let's get a bit more granular on how these systems transfer heat.